Welcome everyone to the webinar, Emerging Technology Platforms to Optimize Operations for the Oil and Gas Industry. My name is Runil Dalia, Principal Analyst here at Lux Research, and I will be moderating today's session. Now, presenting today is my colleague, Thomas Katuki, Senior Research Associate here at Lux Research. Now, throughout the webinar, you can type any questions you have in the questions box on your screen, and time permitting, we will answer all the questions that we can. If your question does not get answered, please don't hesitate to email it to questions@luxresearchinc.com and we will respond. And if at any point you experience technical difficulties, such as a frozen screen, for example, simply refresh your browser and check that your internet connection is strong. Now, let's jump into the presentation and over to you, Thomas.
Thank you, René. Hello, everyone. So today I want to talk about emerging technology platforms to optimize operations for the oil and gas industry. But to start off, I want to talk about some of the continued risks that we are seeing across the oil and gas industry, namely things like operational risks posed by aging infrastructure. And in this case, we've seen several areas where actual leaks from oil have gone unnoticed for days, if not weeks, before being noticed by third parties. To see risks like the volatile oil prices that are changing in the past, as well as they're going to be in the future as well, that impact not only the type of oil that is going to be focused on as prices of the oil, the price of barrel continues to rise or fall, but also the number of bankruptcies that affect the oil and gas industry. Risks like the continuing shortage of skills as an aging workforce retires or moves on from their jobs. Organizations are going to need to figure out how they replace these workers. Are they going to simply hire new workers and train them to do the exact same tasks? Or are they going to supplement them with technological solutions to enhance their capabilities and introduce automation or other tech solutions in areas that are not as attractive for prospective workers? Thinking about risks like reactions to varying degrees of pressures from shareholders in corporations, with the renewed focus on traditional oil and gas revenue and potential changing global and administration aspects, both in the United States and around the world, there's a pressure to focus on the short term while continuing revenues. And while using technology can essentially be used as something to match these short term goals and revenue goals posed by shareholders, but they can also be used to hedge bets against changing administration or regulatory policies 5, 10, 15 years in the future as well. But to meet some of these risks, we have to kind of go into the core technologies that are going to actually shape or prevent or protect companies from the risks that are facing the oil and gas industry. And I'm not just talking about AI, which I'm sure you've read, seen, and heard a lot about, but I'm actually talking about real technologies that can help today and are not essentially trying to promise a product in a black box in the future, like AI, even though we will be talking about AI a bit later in the webinar. But I'm talking about technologies like robotics. Robotics from simple inspection, automated inspection, or maintenance, to all the way up to humanoid robotics, which are seeing hundreds of millions of dollars of investments in 2024 alone. I'm thinking about quantum technology, emerging in currently being utilized technologies like quantum sensing, all the way up to the awesome powers of quantum computing that will help optimize the oil and gas industry through new oil or gas development, through prospecting, or even shipping lanes. And I'm thinking of satellite imagery that is able to provide optical, infrared, and even other forms of advanced imagery to assess potential risks at oil and gas sites, to detect areas that may have damage after weather, or even to look at leaks that can help avoid unexpected downtime. All of these technologies are areas we're going to explore today. But to kind of look at this in a perspective, I want to focus on three major themes. The first theme, regulatory compliance. The second, risk management. And the third, automation. And all of these themes Within them are bucketed a number of technologies that can either impact that core area or a number of areas that can help the oil and gas industry optimize current productions as well as hedge against current risks that they're currently facing or they will continue to face into the future as well. To start off with regulatory compliance, the world as we're currently seeing it has a huge amount of pipelines across it. Whether they're currently active, under consideration, or even currently being constructed, there's a huge amount of pipelines all around the world carrying assets every day. And while a large amount of these might be located in areas, maybe in a city or in regularly populated areas where they're easily observable or there's maintenance available, a larger not. It's very difficult to assess the stability or security of a pipeline, perhaps north of Canada, Siberia, and other remote areas of the world, just due to the cost feasibility. And while it might be possible to hire workers to drive down every kilometer of that pipeline or have a sensor every 5 meters, it is going to be incredibly cost prohibitive, if not dangerous in certain locations, which leads to the need for technological solutions to actually increase the monitoring of these areas. And to start off, there's some technologies specifically that will enable surveying from the ground, as I say. This includes point source sensors as well as several emerging sensors that offer very exact measurements of these emissions, of leaks, from a very small area to a wider area that enables detection over several hundred meters to actually be able to triangulate and quantify where that leak is coming from. However, most of these existing solutions have a limited detection distance. And outside of solutions like the picture represented with long path technologies, they're very focused on a specific area. And while that might be very valuable for critical junctions, for areas that are going to be very important for leaks to be detected, maybe at a production site, at an oil field, it can be less useful because you can't place the same sensor every 5 meters. You need something with a little more breadth to cover that area. Elsewhere, you can then instead use aerial sensors, basically different ways to monitor. And we've seen, heard, and read about organizations using drones, airplanes, or even balloons to monitor these solutions. The idea is you'd have someone, a pilot, a drone operator, or someone else, scan a wide area, whether from a one-time perspective or even regularly, to detect emissions. Maybe this is an emission you've been alerted about and want to triangulate it in. Or maybe you want to go down your entire pipeline every quarter or month to ensure that there are no outstanding leaks or leaks that are minute enough that might turn into something more prohibitive or even lead to downtime. The issue is a lot of these sources are limited by distance, even potentially limited by the time they're able to remain in the air. And while a balloon or a Zeppelin might be able to hover over an oil and gas field for a longer amount of time, a plane or a drone cannot. And a lot of these are also limited by the people who can actually operate them. For example, for pilots, we've heard of pilot shortages in certain regions, and you cannot simply fly a pilot over every single pipeline in the world at the same time. A lot of it might be limited by distance, or in the case of the Middle East, where a significant amount of oil and gas production is located, it might be outright dangerous with some of the current conflicts there, which is going to be prohibitive and make some of these solutions not useful for the oil and gas industry. Which kind of leaves us in a situation where there might be other solutions to explore or even look at. And this is kind of when satellite imagery comes into play. In the past, satellite imagery was operated through cameras or sensors from organizations like NASA, European Space Agency, or even JAXA to detect some of these emissions. But the area they were able to monitor was a little too broad. They might be able to tell you that there was a blowout from a oil field in a certain area of a state like Ohio, but it would tell you several days after, and you'd have to triangulate the rise in gas back to that location. And after a certain point of time, it's still maybe valuable, but you might have already been alerted through that actions by other sources. But over the past 5 to 10 years, a number of organizations like GHGSat and some companies that are going to be launching satellites in the next several years have focused on more point source monitoring, as well as a broader breadth of monitoring as well, that enables detection of methane down to roughly what they hope for, 50 kilograms per hour, but more realistically, 100 to 300 kilograms per hour. But this actually allows the organization and the satellite to focus on a specific location of an oil field. Now, while this might not detect all the regulatory sources, or it won't get down to the regulatory actions needed by several governments around the world, this can be a very useful source of information, whether as a backup to the existing sensors, or in the case of the Permian Basin or a larger oil field, the ability to actually monitor your specific assets next to other assets and potentially even agricultural assets. So if the government comes down and said there is a leak in the area, we're going to find, let's say, several individuals, your organization can actually pull up this satellite data, show that the leak originated from another oil facility or perhaps even an agricultural area with cattle, and say that our oil practices were not the source. Please rescind your fine. And by doing so, can actually affect your public relations as well. So it adds a pretty valuable source of information, especially as some of these solutions continue to grow and increase their applicability for monitoring lower levels of emissions. But that isn't to say that these are the only geospatial monitoring. The United Nations International Methane Emissions Observatory has showcased several of their tracking results. And in the above image, you can actually see some of the sources that they've identified across the world over a period of time. And while some of these include waste or coal leaks from carbon dioxide and methane, a significant amount of them are oil and gas. And with the emergence of Carbon Mapper and Methane Sat to provide this data that isn't just focused on selling it, but actually providing it freely, provides another source of emissions data. Now, this isn't to say that these organizations are going to do your work for you. Their main source is that to actually provide accountability to the world. And a lot of these, like specifically Methane Sat, are run by the Environmental Defense Fund. So they have a very sustainability aimed focus on them to catch polluters. But by doing so, this allows another free source of data, but accountability across the world. If your organization has pioneered an approach to regulatory practices that you want to meet every regulation proposed by your government and be as non-pollutant as you aim, this can help show that other potential competitors are emitting more than you. And maybe that matters to your end customer, maybe allowing you to tack on a price premium or potentially make you the only seller of your oil or gas to that customer. So potentially valuable sources of imagery. And when thinking about some of these solutions, I think there's a lot of them to approach. And I think the biggest idea is when adopting some of these, it really depends on what site or practice you're running. On an upstream facility where you might have a broader set of assets, maybe even some pipelines going, if you're going into midstream, it might be more applicable to both rely on ground-based sensors as well as a multitude of aerial and satellite sensors to track that ground source. But if you're completely downstream, focused on production, or are at a very small amount of sites that are trackable, the ground sensors are going to be more applicable since they have that higher level of quantification. But since they're limited by that distance, they can actually potentially, by only placing, say, 10 to 100 specific types of sensors, or even less, you can be able to monitor your entire sites and make sure that you're regulatory compliant. Moving on to risk management. In risk management, we're thinking not just about safety for workers, which is incredibly important, but also avoiding downtime, which is incredibly important for the oil and gas industry as well. But before we jump into some of these tenets for risk management, I want to talk a bit about computer vision, machine vision, or other advanced vision systems that are currently emerging. And to think about them, there are three broad themes or tracks based on hardware and software that have made this technology so useful. The first is sensors. Sensors have emerged over the past decade or so to become cheaper, cost efficient, and just more optimized, enabling organizations to buy off the shelf solutions for their existing problems, while also waiting for perhaps more exciting technologies like colloidal quantum dots as they try to drive the price down by focusing on consumer electronics to enable higher levels of infrared monitoring. But it's also the algorithms and software that is being developed at the same time. A lot of this can be traced back to what we're seeing with AI, the AI boom as well. But the focus on this enables higher levels of analysis or precision by the actual sensors, enabling higher correlations of data to be able to assess it, where it might take a human minutes to hours to combine that all, or to even highlight differences in infrared technology that are invisible to the naked eye. The third are advancements in processors. The growth of NVIDIA to $1 trillion organization has helped a lot of this, but by running the algorithms on these higher levels of processors, enable the speeding up of several of these optimization problems or algorithms in general that in tune affect the end sensors. And while thinking of some of this, and specifically perhaps the value of computer vision and machine vision and other things, a lot of these sensing types can monitor different solutions. In this case specifically, this is the use of the image, infrared imagery, looking at weld lines on a newly welded pipe. And while there are probably expert welders who can quickly figure out is the weld correct, is it safe, will it last a long time, with the need for perhaps newer workers or secondary measurements, or just to ensure that that welder isn't tired and is going to overlook one gap that can lead to disaster, using things like infrared imagery, perhaps applied with computer levels of software and computer vision, can identify these risks. And this extends beyond just looking at infrared technology. This basically, by using things like optical imagery, infrared technology, you can help mitigate worker risk, increase operational efficiency, and mitigate downtime. Something that is a core focus for a lot of organizations out there, not even just in the oil and gas industry. And thinking about this, there are three specific organizations that we've seen that are exciting by providing sensors, algorithms, and even processing to increase how they monitor or see something and provide value back to the industry. The first is an organization called Groundlight, who has developed an AI software that actually allows kind of feedback, so large language model, for questions asked when imagery is presented. In this case, it provides a question: is the pressure above 200 psi on a specific measurement device? And as you can see, it shows that it is above 200 psi. So by training it and by saying, yes, the indicator does show it is above 200 psi, it can continue to monitor it and learn from, I believe, some of your simple commands. And this provides another level of analysis. Traditionally, a lot of these services might be done by workers who walk to every single readout or a camera that is existing there. But to add that level of, it can say that, yes, that the PSI dipped between 200 for 1 second at that time, that there didn't need to just be an alert, but a monitor, a screenshot, and if it didn't return, then an alert, potentially adds that next level of value to providing that, to help automate a lot of your workforce and existing operations while also reducing these risks. The second is Teledyne FLIR, and specifically their use of their sensors to detect infrared imagery. In this case, this camera is detecting heat signatures on larger vehicles, specifically the heat on the wheels of a large construction device. And this is especially applicable when construction vehicles are carrying large loads down hills, potentially applying their brakes extensively, or maybe running overtime with their engines overheating. And being able to detect higher heat signatures, you could tell specific drivers or vehicles that their brakes have overheated, that their engines are too hot, that their wheels are at risk. And instead of waiting for the brake to fail or the wheel to burst, you could keep that vehicle offline for, say, 10 minutes as that heat dissipated to a safer level, and then to continue operations. So by avoiding it, you can instead avoid a disaster and continue operations through detection of things like simple infrared imagery. The third is by an organization called CDEEP, who is using underwater imagery, believe specifically hyperspectral imagery, to detect instances of issues on underwater pipelines. This could include things like biofouling, corrosion, or even marine growth that might take specific high-powered cameras or actual scuba divers to go down there and analyze the underwater pipeline. And while a large amount of these activities are going to be limited to more shallow areas due to how perhaps difficult it is to measure in deeper water without actually sending that submersible down there, it provides a higher level of analysis that can be used to reduce risks that the overall industry could face and to assess current operations underwater. The next is kind of going back to a bit to looking at satellites and how satellites are applicable not just in regulatory compliance, but also in risk mitigation as well. In this case, satellite imagery, and thinking specifically about synthetic aperture radar, which is the use of radar waves to reflect on the ground, and reflect back to the satellite, and to measure how that might change. Specific instances with synthetic INSAR, which is by using two of those to detect perhaps ground change at a millimeter level, satellites can actually predict or assess the change in ground. So in the picture above, you can see ground subsidence and how it has affected an area that has a pipeline and a road. And by being able to perhaps assess ground changes at a millimeter level on a monthly, quarterly, or even yearly basis, organizations such as Inspective have actually been able to predict things like sinkholes 30 days before they actually occurred. If this sinkhole was at an oil facility or even below a pipeline, this would allow organizations time to go out there and perhaps more affordably repair that site or reinforce that site before a sinkhole collapsed the pipeline, which would lead to both an environmental disaster as well as a large amount of downtime for your organization. The next type, and specifically looking at some of the project risks within that, is the use of emerging technology for quantum sensors. Quantum sensors are still at an emerging level, and while they're currently being tested and used in some commercial applications, they're still some years off before their applicability is going to be more widespread. But at an early level and with some early commercial testing, we've seen several instances where they're already applicable to the oil and gas industry. The first that we're seeing is GPS and the position, navigation, and time area, where they actually provide an alternative to that. And this could be incredibly useful if you want to get a more narrow measurement of a vehicle or a tool or even a robot that's moving, but also in areas that perhaps where if you're submersed underground or you're automating a robot in an area that is in a GPS denial area, perhaps because of it's in a lead encasing or inside a building, but you need that exact measurement. Quantum sensing could provide that X level of awareness. Other areas that we've seen are detection of corrosion pit, and specifically in this image on the right, this quantum sensor was able to detect corrosion at a very small level on existing facilities, and being able to test that at critical junctions could be incredibly important to assess corrosion before it becomes a wider spread issue. And quantum sensing exists beyond these areas as well, being able to be used in detecting gravitational movements of land, as well as being able to assess the applicability of what might be under the ground before construction actually goes into place. In the past, we've seen gravimeters on springs being used that can take a large amount of time to actually set and can be disrupted by current construction on the site. But to instead know through the use of quantum sensor what you're actually cutting into, constructing, or drilling into, especially when it's an area that might be new or you might not have underground estimates or readings of, is very useful in reducing risk of a project. And thinking specifically of all of these types, while several of these technologies, perhaps the satellites and the quantum sensors, are very exciting, they're also probably not the first technology people should jump into as they look at some of these projects for adjusting risk. Things like computer vision, whether it's a new sensor that is being used with your already existing algorithms, or taking the sensors and cameras you already have and applying another level of AI or algorithm technology to that, to detect the readings, is going to be a lot more valuable across organizations, and especially for organizations who haven't started this process yet. So now we jump into the third part of our technology coverage with automation. And automation isn't just about robots. There's a lot of robots in it, but it also extends to several other areas as well. And I kind of want to start first with a bit of the struggles of robots and automation in general, moving from the factory floors where there's very clean areas, they have bright lights, they have a set path, they go from point A to point B on a walled off area or taped off area, to areas where there are dirt, snow, heat, different shaped grounds, workers who may not have seen the robot before. And it's very difficult. Moving from low variability to high variability, from a structured to an unstructured environment, has been very difficult for robots. Several robots have started to move to that mid-level, that semi-structured area, but the value is still very broadly within these structured environments. And to kind of give an example of some of that difficulty, one example we heard was an organization had looked at a robot for automated inspection. They wanted to replace their workers who were in areas where they were limited by OSHA regulations due to heat, with a robot to then inspect in an area. However, the workers were only limited for 4 hours, but when they put the robot specifically in there, it failed within half an hour, kind of showing that even though some of the automation solutions can be applicable and can be fit within the perhaps structured environments, as you go into this higher levels of variability where there are more extreme temperatures or conditions, it can impact what is already being assessed or approved for these structured environments. But kind of looking beyond there are a number of organizations that are already developing, or are going to develop solutions that are applicable within the oil and gas industry. Thinking about organizations like Gecko Robotics, which are providing crawling robots to go on oil and gas assets for inspection across the world, who already have these robots in the field to provide additional levels of safety or automation for your workers, to not build scaffolding to have a worker up there to create risk for that worker, but to instead have a worker monitor that robot as it goes to an area that's high up in the area. Organizations like Nauticus Robotics, who are developing underwater robots or submersibles to do inspections on perhaps oil pipelines or even under ships. Another is Applied Impact Robotics, who is just beginning to do their benchmarks or pilot projects by having a Roomba-like robot actually be submersed in what I believe is oil to clean the tanks as there is still a liquid inside. So that acid doesn't need to be, that oil or liquid doesn't need to actually be removed and have people come in there and clean it. But they can actually speed up the process and automate it, so workers who might not want to apply for those jobs don't need to be continued to relied on as much, or you can fill those jobs up a lot more easier with the inclusion of robots. But also thinking about the promise of humanoid robotics. And while the ideas, there's a lot of interest in kind of augmenting existing worker-robot relationships with humanoids, and especially perhaps placing these robots in areas where they are risky or dangerous areas, humanoids are still far out. And in the future, there might be applicability, but at the moment, they're still performing, let's say, with lifting boxes and moving them at a supply chain site at speeds that might be at 10% of what we'd like human workers to be. But these are all still very exciting technologies within broader automation. But there are still other technologies that are being developed that have a lot of applicability. Mechademic is an organization that develops high precision robotic arms that are able to lift objects up to 500 grams or even 1 kilogram, but at what we've seen is the highest level of precision from robotic arms in the world. And this could help automate existing laboratories for research and development, for lab workers, for your scientists who are developing catalysts or new developments for oil and gas. This could help automate how they're testing lab work, trying to find solutions and automate that instead of having to use human labor continuously. It could speed up that and make it a lot easier. I'm thinking about organizations like Revolut Robotic, who have not only developed a drone that can be flown or driven around to inspect sites or areas, but can actually land on the ground and drive. So it's not prevented by obstacles that might prevent it from flying or that would impact this cage as much, but to provide another source of automation or monitoring so that pipelines, assets, and even certain areas can be inspected without having to have humans continuously go around or walk around a site. And thinking about organizations like Telia, who have actually developed and started to develop self-driving or semi-autonomous construction vehicles, where instead of having 10 to 20 workers at a construction site using excavators to dig dirt or move land around, you might have several construction vehicles monitored by one worker 50 kilometers off-site who would step in at key moments or for digging capabilities. But for the broad set of moving dirt from point A to B or digging a hole in this location can be done through automation and some minor teleoperation. So all of these areas provide automation in areas that can help enhance the current workforce, as well as provide operational improvements across the organization. But it's not always just about robots specifically. It's also about automated intelligence as well. Specifically, satellites and sensors provide third-party monitoring and other solutions. And this isn't just about automating or the actual data they're gathering, but it's also about having something that sticks around for 24 hours a day, 7 days a week, to figure out what is happening at a certain location. And specifically with the bottom picture, this is for monitoring the level of oil or gas at facilities around the world. Maybe if you want to ship to a certain location and make sure that they have storage available, or that they need oil or gas and might be able to pay a higher premium to have it delivered that day. In the past, a lot of these, such as counting ships in a harbor or how many trucks have left the site, have been left to the people to stand on top of a building and mark how many ships are waiting to deliver, LNG to a port. But satellites instead could take that same picture every day or every hour, as often as you'd want, and to provide that data without sending someone up there and wasting their time. It can also detect specific trucks who have arrived at a site to alert a worker to come and greet that worker, or even let security know or organization know if the underground area of where a pipeline is moving across land we've leased with a worker has an underground illegal activity or underground encroachment, or that a farmer hasn't mistakenly started farming over that area, and the risk of hitting that pipeline and opening it, leading to downtime, could occur. All of these add additional levels of intelligence that are incredibly useful, and to provide that automation so that you don't need dozens of people watching the same object or same area, that you can instead rely on this automated intelligence. And thinking a lot about these technologies and specifically where they might align, I think if organization has started with some of these, looking at some of the lower hanging fruits, especially with robotics, whether it's automating inspection or providing security or maintenance, is very important. That helps jump up to current operational efficiency levels. It introduces broader sets of automation, and it can actually help increase the issues that you might be discovering but that you might also be reporting on or looking for as well as continuing maintenance around the site as the startups and other organizations continue to work towards more value-adding robotics across the field. So thinking about these specific areas, regulatory compliance, risk management, and automation, they can also be broken down into some roadmaps for implementation. And these are implementation ideas that can occur now. So after this talk, you could actually go out and say, we want to implement computer vision or satellite imagery into our organization. But there are some that are going to be distant as well, or distant to where their value is actually going to be seen. So if your organization if you're a CVC operator and you're looking to make investments that not only have a return on investment, but it can also increase the value provided to your organization. Things like quantum computing might not have as high of a return now as it will have in the future. So instead, investing in things like quantum sensors will have a higher level of both financial and operational return for your organization. That isn't to say that quantum computing is going to take that long. There's a much broader roadmap for the actual implementation that needs to be taken to successfully operate these computers. But thinking strictly within investments, that is one solution. And if you're looking to increase operational efficiency through, let's say, monitoring leaks or risks that could happen and avoid unexpected downtime, going out there and thinking specifically within strategic intelligence and utilizing things like computer vision and robotics to assess sites and to automate that assessment and perhaps even repair, now is going to be very valuable as they're working towards things like emerging greenhouse gas sensors, which provide that broader as well as exact sense of analysis for emissions. And as you kind of hope for humanoid robotics to be developed that can actually assess the site and do the action. So there's a lot of actions that can be taken now as you try to meet the growing needs or demands of shareholders, of executives, of the industry at large, while preparing for the future as well. By simply focusing on AI or another future project, you're hoping for a large transformational impact. And while that will happen one day, it might not happen tomorrow. And for a lot of these solutions, they provide value now as well as value into the future, value that can help bridge that gap between that massive transformational project, which will increase the growth and optimization of the organization, but that these technologies will provide growth and revenue now, as well as enable you to hedge risks against any change in global crises or politics or policies or even economics that might face the oil and gas industry into the future. So as I leave today, I want to talk about some key takeaways. Specifically, the first is that by focusing on automating near-term compliance and productivity challenges, it helps free operational teams to pursue these long-term innovations. As I mentioned, organizations are focusing on both, but by focusing on the near-term solutions in conjunction with the long-term solutions, it helps you see value from these technological integrations and growth now as you work to these longer moonshot projects that are going to be transformational for your organization. The second is that specific use cases should align with the key values of your organization, whether that is regulatory compliance, risk management, and workplace productivity. All of them or even one. It shouldn't just be technology for technology's sake. The technology should align with your key goals and have a very key readout into these areas and the value they provide. And the third is that these autonomous technologies do not always cohere into a safe, risk-free, and cost-effective drop-in solution. It takes time to integrate these technologies. In the case of what we saw with the robot trying to replace OSHA regulations, or some satellites not being able to monitor things at a certain level all the time, it requires a while to adopt and successfully integrate and even manage these technologies and see value. And when you're looking at some of these technologies and specifically aligning them with the key values of your organization, you should be prepared that it might take several months or even a year to see that high level of efficiency and for the organization to kind of completely align with that technological solution as well. So thank you. I hope the chat was enjoyable, and I appreciate everyone being here today.
Great. Thank you very much, Thomas. So we will now be taking questions that you may have on the presentation, which you can type in the question box. And if, as I mentioned earlier, if we do not get your question on this call, then someone from Lux will be in touch shortly after the webinar. But I see a few questions already coming in. The first one that we received, Thomas, is around quantum computing. The question is, when is quantum computing going to be impactful for the oil and gas industry?
That's a very good question. Quantum computing has a very wide or broad area of impact. At the moment, quantum computers are still very much at an R&D level, or even a laboratory within your own organization. But over the next few years, we actually start to see them having a very low level impact, still at that research level. But within the oil and gas industry, and this can be a much larger conversation that I would enjoy having follow-ups on as well, it will probably be into the late 20s, if not into the 30s, where we're going to actually see that commercial impact. That isn't to say that organizations should not start focusing on quantum computing. Today is actually the best day to start looking at it, because unlike with traditional computing, where you might have software, to actually utilize these computers, you need to translate all of that software into quantum algorithms. And you need certain experts to take advantage of that as well. So to kind of answer that question, quantum computing will be commercially impactful for the oil and gas industry, most likely in the late 20s or mid 30s. But the time to start looking at it is today.
So on the topic of timeline, there were a couple of questions around more near-term opportunities for the oil and gas industry. So are there any other examples of technologies that you think can impact the oil and gas industry in the near term?
Yeah, so I would say a number of the gas sensors that are currently being developed are really interesting, specifically using photonic or LiDAR detection. As I mentioned, Long Path Technologies is currently expanding and doing a lot of site tests that would be able to assess the quantification of emissions at an oil and gas facility several hundred meters away, which kind of gets you to the level of point source monitoring at a much broader area. But it's also the kind of rollout of satellite organizations like AIRMO, who claim to be able to monitor emissions at 50 kilograms per hour, which I believe is similar to what current airplane organizations are trying to offer for flight emissions, being able to monitor the emissions as well. So both of those would offer basically a higher level of quantification at a much broader area, which could be very attractive for risk mitigation, regulatory compliance, and even automation in some cases.
All right. So there's a few more questions that I see, but unfortunately we don't have the time to answer the questions. But as I mentioned, someone from Lux will be in touch with you with regards to your question after the webinar. So thank you very much, Thomas. That concludes our webinar for today. The slide presentation and the recording will be sent to all the attendees via email today itself. And after leaving the webinar, you will be prompted to complete a survey on today's presentation, and we would appreciate any feedback you have to really help us inform and improve future webinars. So take a moment and check out our upcoming webinars, and thank you very much for joining us, and have a great day, everyone. Thank you.